So a very good afternoon to all of the students present here. It's 3:10. Actually, the class I am taking on behalf of SKG sir, because now today the scholarship distribution is going on. So I thought of discussing with you about the Datalink layer. Maybe it is known to you, but the GATE class will be done on Friday. That is NB sir will be taking the class. Okay, so this is the thing, and let's start with the Datalink layer and some of the protocols that you have already done. I am not asking the same thing, but as part the GATE syllabus is concerned, this is very important. Now you know that Datalink layer is the second layer from the top of from the bottom of the TCP/IP model or OSI model. Now in this case you have seen that the main responsibilities will be flow control and error control. Otherwise there are other responsibilities are there. Okay. Now in this case it is relevant to mention that what do you mean by error control? Error control, three types of error controlling mechanism you have seen in previous class in the data communication itself. You have seen the ARQ concept. AT sir have told you the three types of ARQ you have studied: stop and wait ARQ, followed by the. Is it clear to you all? Because my headset it is fine. Can you listen? It's already there, right? Okay. So three types of ARQ: stop and wait ARQ, go back in ARQ, and selective repeat ARQ. Three things we studied in the previous class. I just like to focus on the three topics just for sake of recap, because in this semester also you are having the same thing, the first two layers. I hope that is a part of the SND sir. So in this case we will be learning that what do you mean by the data link control. So as we know, the transmitters that can be sending the data rate which is much higher in nature, okay, and the receiver may not be capable of taking that high data rate. So you need to put some buffer in between, so that there should be some balance between the incoming flow of the data and the whatever the incoming flow from the transmitter and whatever the receiver is going to receive it. So that I wanted to focus here, that the data must be checked and processed before it can be used. The rate, this is very important, rate of such processing is often slower than the rate of transmission. It happens. So whatever the transmitter that is sending, that is in the order of, in suppose in normal case like the fiber optic cable in the ring network that we send in the order of Gbps, but what the output you are getting in the modem, that is the data rate that the modem is supporting is quite less, right? So how this rate difference is going to be managed, that is actually managed by the data link control. Okay, so if there is some buffer, the concept of buffer will be there to have a balance in between these two. Now flow control refers, you know, this is a set of procedures will be there that is used to restrict the amount of data that the sender can send before awaiting for acknowledgement. So the acknowledgement concept is there. And if I talk about the ARQ, I hope it is known to you. I am not asking for the new thing. Now in case of ARQ, you know that mainly there will be two types of the flow control. If I talk about, so if I talk about the flow control mechanism, there will be two cases. One will be for the noiseless channel, another will be for the noisy channel. Okay, so when you are going for the noiseless channel, another is for the noisy channel. Okay, now in this case you will be normally having the protocol like the stop and wait, and for the noisy channel you will be having three scenarios. First one will be like you will be having stop and wait ARQ, the second one will be go back in ARQ, and the third one will be selective repeat ARQ. Okay, it will be just stop and wait, next is the go back in. Anyways, you can think of go back in and selective repeat ARQ. Now in this case I just want to say one thing, that when you are going for the stop and wait ARQ, what you have seen there, the first one, in this case it works on the simple assumption that the communication channel is purely perfect and there is no error when I am talking about this stop and wait. Okay, but when there is some concept of acknowledgement, we will be going for this ARQ concept that is given here. So in case of this ARQ, you can see here error correction or error control or flow control, all these things are there. So you can think of that this is the stop and wait, another sliding window is there, in between that you have go back in, and where in is the window size. Now I am talking about the simple stop and wait ARQ. So this is the simplest case. Here you can find that the transmitter will be sending the frame and it is going to be in the waiting state for the acknowledgement. So until and unless it is getting the acknowledgement, it is not sending the next thing. Okay, so this is the thing you can find, that the transmitter will send the signal, whatever the data it is sending. So the next signal or next data it is not going to send until and unless it is getting the acknowledgement from the receiver. So the sending device keeps a copy of the sent frame transmitted until it receives the acknowledgement. So this is the concept. You can see here this one. Anyways, the second point I have shown that the sender starts a timer, so a timer will be started. Okay, so you are sending a frame, so a timer will be started while you have sent a frame. So if an acknowledgement is not received within the allocated time period, the sender is going to resend. So if I am asking some question, if you are not answering me within the stipulated time, then I will think that I have to re-ask the same question, just like that. So both frames and acknowledgements are numbered alternatively 0 and 1, so that I will be showing, and the numbering allows for the identification of the frame in case of duplicate transmission when the retransmission concept is there. So why we are using the numbers, because we want to notify how many frames we are transmitting, and that for that reason also we are numbering the scheme. Okay. Now this is the normal stop and wait. So suppose the packet 0, so numbering is the 0, 1, these are the numbering scheme we are talking about. So when you are sending some packet, the acknowledgement will be there from the receiver end back to the sender end. Okay, this is the acknowledgement. So for packet 0 you are getting the acknowledgement 0, for packet 1 you are getting the acknowledgement 1, like that. Okay. Now what I told, the sender will keep a track of the packet, what he has or what it has sent. So if it is unable to get the packet, suppose somehow due to some distortion the acknowledgement is lost or packet itself has not reached to the destination. So what is the solution? It is going to retransmit it. Okay. So for that reason, so what it is going to retransmit, so it should have some predefined, or it should have saved the packets, because it doesn't know that whether until and unless the acknowledgement is received, so it is going to retransmit it, but definitely it is going to save it. So it should keep a record of each of the packet that it sends. And to avoid confusion caused by the overlay or duplicate acknowledgement, the stop and wait sends each packet with unique sequence number. So I will be telling you about the sequence number. Now what I was discussing in the last slide, so in two cases the acknowledgement cannot be reached to the receiver. Suppose for the first case it has sent packet 0, but the acknowledgement has not yet reached. So after certain time, this is basically the time after which the sender will again retransmit the same packet. So the retransmission of packet 0 will be feasible after certain time. That time is known as the timeout. Okay, and for this case, second case, it has already got the acknowledgement within the stipulated time. There is no issue. So there will be two cases, and second case first case the acknowledgement is not at all received, and the second case is the packet is lost. So for both the cases you need to retransmit. So there will be two cases. Okay. So first the acknowledgement is lost, second one the packet itself is distorted. Okay. In both the cases it is going to retransmit the same thing. So it is the simplest thing, that is the advantage, but the disadvantage is the thing that each frame must travel across all the way to the receiver, and an acknowledgement also travel both the way before the next frame is sent. So every time both the thing you can see, it is sending then receiving. So this both way it is sending the data as well as acknowledgement, and that is quite inefficient in nature. Now if one by one, instead of sending one by one packet, suppose for the first case stop and wait hierarchy, you are sending the first packet, then you are receiving, then if you have not received, then again you are sending. So one by one you are sending one packet after one packet. So what is the alternate way to get the better result out of it, or to use the pipeline concept? Pipeline you have used in COA. So the concept is like that, you are using multiple data, or you are sending multiple bits at the same time, but there are two subdivision of that also, go back in and selective repeat ARQ. So for both the cases, how the efficiency will increase, that we can see. So no pipelining concept was there in the first case, but second and third we will be using the concept of pipelining. So what is the main advantage of this? I am just going to underline this one. The multiple frames can be sent at the same time. That is the advantage of this type of sliding window. So both the technique, whether it is go back in or selective repeat, these two are known as the sliding window protocol. Okay. Now sliding window size, in case of go back in, the n value is the window size, like you can say go back 3, so 3 will be the window size, or go back 5, so this will the 5 will be the window size. That is the, and that window is going to be moved after the transmission. So how it is going to happen, let's see. Now one thing I like to mention here, which layer it is going to work. So Datalink layer, that is a layer 2 of OSI, as well as the TCP, that is a network layer also, both the cases that is feasible. Okay. Now the second thing is the go back. So it is a second for noiseless channel, this is the second technique we will be using, and here we can find like go back 3. N value is nothing but the window size that we have studied. Okay. Now what do we mean by this? Let's see here. all the theories are there, but still we can just for sake of remembering this one we can think of. Now when we are observing go back 3, I am repeating once again, when we are observing go back 3, what it means? So ultimately there will be 3 frames, frame number 1, 2 and 3, that can be sent before expecting the acknowledgement of frame 1. Previously one frame was sent, then the acknowledgement of first frame will be received, then we will be sending the second frame. But in case of go back n, we will be sending 3 frame or 5 frame. How it matters? What is the value of this? N value. What is the value of n? That many number of frames we will be sending before expecting the acknowledgement of frame 1. That is the scenario. Now the second point that it shows that in go back in ARQ the frames are numbered, that I will be showing you in the next slide, and it will be sending multiple frames at a time. Note this, at a time that requires numbering approach to distinguish frame with another frame. So you need to distinguish it, so that frame numbering is important. That numbering, normal frame number is there and sequence number is another concept. That is, if the window size is 4, the sequence number will be 0, 1, 2, 3 like that. Okay. So the number of frames that can be sent at a time totally depends on the size of the sender's window. So all these things are there. Let us see the example here. So when we are sending, suppose go back in ARQ, here the n value I have taken 4. Okay, the n value I have taken 4. So when you have taken the n value 4, so how many frames are there? There are basically 11 frames, frame 0, 1, 2, 3, 4, 5 up to 10. So there are 11 frames that are there, and you have selected a window size of 4. That is, this window will contain the first 4 packets, right? So what is the sequence number here? The sequence number will be 0, 1, 2, 3, again 0, 1, 2, 3, again 0, 1, 2, 3, so on, until and unless you are just reaching to the end of the frame. Now for this case you have sent, the first 4 frames, okay, sorry, for the first 4 frames, and then whatever it is happening, the window will slide here. That's why the moving window or sliding window protocol will happen. Okay. Now after sending 4, there should be some acknowledgement, right? So after sending the 4 frame, the acknowledgement of frame 0 will come here, okay, and then the receiver will get the acknowledgement of the frame 0, and after getting the acknowledgement of frame 0, what it is going to do, you can see here that the window slides from 4 frames, 1, 2, 3, 4. So previously it was like 0, 1, 2, 3. Now the window has been shifted towards this. You can see the previous slide that it was 0, 1, 2, 3, the window was this, and now after getting the acknowledgement of frame 0, it has been shifted towards this. Now it will be 1, 2, 3, 4. So see here, this is the 1, 2, 3, 4 will be the new sliding window. That's why the window has been slided from this portion. Then what is the new frame you have achieved here? The frame number 4. So the frame number 4 that you have achieved, now you will be sending via this. Okay. So what is the next thing? The receiver will then send the acknowledgement from frame number 1, because the 0 you have already obtained here, then only you have sent frame number 4, and then the acknowledgement of frame number 1 will be arriving here, then you will be sending frame number 5 like that. So, and you can see here again the window has been slided towards this. Okay. So now the sliding will be 2, 3, 4, 5 like this. So this is the way the thing is going to happen. Now the problem arises, suppose when you are sending some frame and ultimately the acknowledgement is not received. Suppose this frame, the frame number 2, you have sent it, just like 0 you have received the acknowledgement, for 1 you have received the acknowledgement, then the 4 and 5 has been sent subsequently, but for frame number 2 you have sent it but you have not received the acknowledgement. So what is the scenario in that case? In that case the scenario is like that.